Hello guys, hope you all are doing well. Scared about technical interviews? Well, don't be anymore. So today we are going to learn an interesting problem called Tower of Hanoi, which is a common interview question. Before proceeding to the problem, there will be an interesting question at the end of this video. Try to answer it correctly and the first comment is announced as winner in the next video. So stay tuned until the end of this video. Now let's jump into the action. The problem is there are three towers named as A, B, C or 1, 2, 3 and one of the tower is having a stack of rings in decreasing order of sizes from bottom to top. We have to transfer all these rings from tower A to tower C by the following conditions. The conditions are: we have to move only one ring at a time, the only top ring can be moved, that is, taking from the top of one tower and placing on the top of another tower. Larger ring cannot be kept on a smaller ring. The third condition is this one. By these conditions, we have to move all the rings from tower A to tower C. For moving all these rings from tower A to tower C, we may require an extra tower, so tower B is given as an auxiliary tower or using tower. The problem is not so easy. It is believed to be an unsolvable problem. There is a story behind this problem. It is believed that somewhere in the world there is a temple, and near the temple these three towers are there. And there is a tower with 16 golden rings. And few priests are trying to move all the rings from tower A to tower C, and they are doing it from centuries. If they are successful, then the world will end. That will be a doomsday. This is the story behind this. So, this was believed as an unsolvable problem. But this problem can be solved using recursions. Let us learn how recursion helps in solving this problem. So we want what should be the moves such that the rings can be transferred from A to C with the help of B. Now I have taken three problems. Here is the first problem with a single ring, and second problem with two rings, and third problem with three rings. There is only one ring, then the solution is very simple. Move a ring from A to C using B. Though we are not using B because there is only one ring, but I am writing it, that will help me in writing down other procedures. Here is the solution for two rings. Move the topmost ring from A to B using C, but B is not the destination tower, it is an auxiliary tower. Now as C is the destination tower, move a ring from A to C. Now move a ring from B to C using A. Now A is an auxiliary tower. Here I am not starting from the source or beginning tower, I am starting from B, so I am using the word using here. And finally this is done. So these three steps has to be followed for transferring two rings from tower A to tower C. Now there are three rings in tower A. Now we can call this problem as complex. To make this problem simple, just say that we are moving two rings at a time. We already know how to move two rings from A to C, so that take three steps. So we have to follow those three steps to move two rings from one tower to another tower in this problem. Just for our convenience, I am telling we are moving two rings at a time. Move two rings from A to B using C. Now move a ring from A to C. Then move two rings from B to C using A. And finally this is done. We have followed these three steps for transferring three rings from tower A to tower C. Now from this three rings procedure, we can generate the idea for n number of rings. When there were three rings, we wrote it as two rings. When there were four rings, we write it as 3. When there were n rings, we write it as n minus 1 rings. So these steps are repeated in the same way. Now these steps has to be followed for transferring n rings from tower A to tower C. This is the recursive algorithm for Tower of Hanoi. We can compare those three steps with the algorithm. The algorithm is, if there were n rings and 3 towers as A, B, C, if number of rings are greater than 0, then follow this procedure. The first step is a recursive step with n minus 1 rings and A is the source, B is the destination and C is an auxiliary tower. And next step is the moves such that the rings can be transferred from A to C. And C is also a recursive step with B is the source, C is the destination and A is an auxiliary tower. So this is the algorithm we have devised based on the 3 steps. Now let's look at the recursive tree for this problem. As we know the working of recursion, which is first call has to be finished, then it will print this one and call this one. So this recursive call has been expanded. After one ring, the next call is for 0 ring. We given a condition, the number of rings should be greater than 0 to transfer the rings. As number of rings equals to 0, it also consider this recursive call because it checks the condition for n greater than 0. As n equals to 0, so it terminates, but call has been made. Now let us understand how many recursive calls has been made when number of rings are 3. So this is the first recursive call, this is the second recursive call, this is the third, fourth, fifth, sixth, 7th, 8, 9, 10, 11, 12, 13, 14 and 15. So total 15 recursive calls has been made when number of rings are 3. When number of rings are 2, this is the first recursive call, this is second, third, fourth, fifth, sixth, 7th. So total 7 recursive calls has been made when number of rings are 2. Now we know this is the first call, this is the second call, this is the third call and this is the first move. This is the second move, this is third, this is fourth, this is fifth, this is sixth, this is 7th. So total 7 moves has been made when number of rings are 3 to transfer all the rings from tower A to tower C. Now let's look at the code for tower of Hanoi in C++. This is the function name as TOH and passing 4 parameters as number of rings and A, B, C as tower names. If number of rings are greater than 0, then follow this procedure and in the main function, take the number of rings and pass to the function. So this is the output for our problem. So these moves has to be followed to transfer all the 3 rings from tower A to tower C. If you want to find for 4 rings, just take n equals to 4 and pass to the function. So these are the moves we have to follow for transferring all the 4 rings from tower A to tower C. Now let's conclude our problem. If number of rings are 2, then 7 calls have made, which is 2 power 3 minus 1. If number of rings are 3, then 15 calls have made, which can be written as 2 power 4 minus 1. Similarly, if number of rings are n, then 2 power n plus 1 minus 1 calls have made, because if number of rings are 3, total number of calls made is 2 power 3 plus 1 minus 1. So which is in the order of 2 power n, which is exponentially time taking problem. So from this we can conclude that the minimum number of moves made by 3 rings is same as the number of recursive calls made by 2 rings. Here the number of recursive calls made by 2 rings is 7, so the number of moves made by 3 rings is also 7. So from this, the minimum number of moves made by n rings is same as the number of recursive calls made by n minus 1 rings. This is the challenging question for you. Submit your answers in the comment section. Please like, share and subscribe to our channel.